The Intelligent Platform Management Interface is a set of computer interface specifications for an autonomous computer subsystem that provides management and monitoring capabilities independently of the host system's CPU, firmware and operating system. IPMI defines a set of interfaces used by system administrators for out-of-band management of computer systems and monitoring of their operation. For example, IPMI provides a way to manage a computer that may be powered off or otherwise unresponsive by using a network connection to the hardware rather than to an operating system or login shell. The development of this interface specification was led by NEC Corporation and is supported by more than 200 computer systems vendors, such as Cisco, Dell, Hewlett-Packard, Intel, and NEC Corporation, SuperMicro and Tyan. Functionality: using a standardized interface and protocol allows systems management software based on IPMI to manage multiple disparate servers. As a message-based, hardware-level interface specification, IPMI operates independently of the operating system to allow administrators to manage a system remotely in the absence of an operating system or of the system management software. Thus IPMI functions can work in any of three scenarios: before an OS has booted, when the system is powered down, after OS or system failure. The key characteristic of IPMI compared with in-band system management, such as by remote login to the operating system using SSH, system administrators can use IPMI messaging to monitor platform status, to query inventory information, to review hardware logs of out-of-range conditions, or to perform recovery procedures such as issuing requests from a remote console through the same connections, for example system power down and rebooting, or configuring watchdog timers. The standard also defines an alerting mechanism for the system to send a simple network management protocol platform event trap. The monitored system may be powered off, but must be connected to a power source and to the monitoring medium, typically a local area network connection. IPMI can also function after the operating system has started, and exposes management data and structures to the system management software. IPMI prescribes only the structure and format of the interfaces as a standard, while detailed implementations may vary. An implementation of IPMI version 1.5 can communicate via a direct out-of-band local area network or serial connection, or via a sideband local area network connection to a remote client. The sideband LAN connection utilizes the board network interface controller. This solution is less expensive than a dedicated LAN connection but also has limited bandwidth. Systems compliant with IPMI version 2.0 can also communicate via serial over LAN, whereby serial console output can be remotely viewed over the LAN. Systems implementing IPMI 2.0 typically also include KVM over IP, remote virtual media and out-of-band embedded web server interface functionality, although strictly speaking, these lie outside of the scope of the IPMI interface standard. DCMI is a similar standard based on IPMI but designed to be more suitable for data center management. It uses the interfaces defined in IPMI, but minimizes the number of optional interfaces and includes power capping control, among other differences. Sideband and out-of-band, as well as using a separate dedicated management LAN connection, IPMI also allows implementation of a so-called sideband management LAN connection. This connection utilizes a system management bus interface between the BMC and the board network interface controller. This solution has the advantage of reduced costs but also provides limited bandwidth or a euro sufficient for text console redirection but not for video redirection. For example, when a remote computer is down, the system administrator can access it through IPMI and utilize a text console. This suffices for a few vital functions, such as checking the event log, accessing the BIOS setup and performing power on, power off or power cycle. However, more advanced functions, such as remote reinstallation of an operating system, may require a full out-of-band management approach utilizing a dedicated LAN connection. IPMI components. An IPMI subsystem consists of a main controller, called the baseboard management controller, and other management controllers distributed among different system modules that are referred to as satellite controllers. The satellite controllers within the same chassis connect to the BMC via the system interface called Intelligent Platform Management Bus Bridge, an enhanced implementation of ES²C. The BMC connects to satellite controllers or another BMC in another chassis via the Intelligent Platform Management Controller Bus or Bridge. It may be managed with the Remote Management Control Protocol, a specialized wire protocol defined by this specification. RMCP+ is used for IPMI over LAN. Several vendors develop and market BMC chips. A BMC utilized for embedded applications may have limited memory and require optimized firmware code for implementation of the full IPMI functionality. Highly integrated BMCs can provide complex instructions and provide the complete out-of-band functionality of a service processor. The firmware implementing the IPMI interfaces is provided by various vendors. A field replaceable unit holds the inventory, such as vendor ID and manufacturer, of potentially replaceable devices. A sensor data record repository provides the properties of the individual sensors present on the board. For example, the board may contain sensors for temperature, fan speed, and voltage. Baseboard Management Controller. The baseboard management controller is the intelligence in the IPMI architecture. It is a specialized microcontroller embedded on the motherboard of a computer, generally a server. The BMC manages the interface between system management software and platform hardware. Different types of sensors built into the computer system report to the BMC on parameters such as temperature, cooling fan speeds, power status, operating system status, etc. The BMC monitors the sensors and can send alerts to a system administrator via the network if any of the parameters do not stay within preset limits, indicating a potential failure of the system. The administrator can also remotely communicate with the BMC to take some corrective actions such as resetting or power cycling the system to get a hung OS running again. These abilities save on the total cost of ownership of a system. Physical interfaces to the BMC include SMB-US buses, an RS-232 serial console, address and data lines, and an intelligent platform management bus that enables the BMC to accept IPMI request messages from other management controllers in the system. A direct serial connection to the BMC is not encrypted as the connection itself is secure. Connection to the BMC over LAN may or may not use encryption depending on the security concerns of the user. There are rising concerns about the general security regarding BMCs as a closed infrastructure. Security. On July 2, 2013, Rapid7 published a guide to security penetration testing of the latest IPMI 2.0 protocol and implementations by various vendors. Vendors have provided patches that remediate most of the vulnerabilities, but the IPMI 2.0 RAKP authentication remote password hash retrieval vulnerability has not yet been addressed. This arises from the difficulty that the IPMI 2.0 specification is flawed in that it reveals the password hash and SALT to anonymous remote clients. This allows for offline brute force attacks. Complete remediation will require a change to the IPMI specification. Some sources are even advising against using IPMI at all, due to security concerns related to the design and vulnerabilities of actual baseboard management controllers. Version history. The IPMI standard specification has evolved through a number of iterations. V1.0 was announced on September 16, 1998, base specification. V1.5, published on March 1, 2001, added features including IPMI over LAN, IPMI over serial modem, and LAN alerting. V2.0, published on February 14, 2004, added features including serial over LAN, group-managed systems, enhanced authentication, firmware firewall, and VLAN support. V2.0 revision 1.1. Published on February 11, 2014, amended for errata, clarifications, and addenda, plus addition of support for IPv6 addressing. See also, out-of-band management, management component transport protocol, HP integrated lights out, Dell DRAC, IBM remote supervisor adapter, Mega RAC, Avocent merge point embedded management software, Intel active management technology, DMTF alert standard format, DMTF desktop and mobile architecture for system hardware, system service processor on some SPARC machines, wired for management, references. External links.